All right, so here's this is going to be notes on just the accuracy of Riemann sums. And the actual area under the curve, so I have the same graph. The actual area under the curve is this bottom one where I shaded all of this area in. And I just went from like this point A over here to some point B over here. But the actual area under the curve, it's just whatever space is under the curve, it's that area. So however much space is under the curve, that's the area. And these are all going to be different levels of accuracy. And sometimes they over approximate, sometimes they under approximate. Left hand ones don't always under approximate. It depends on the concavity. So if you have a linear line, like if the slope is increasing, you can see this left hand, it's underneath. So I'll highlight this extra space is left over. So right now it's under approximating. And a lot of times what you'll see that referred to as is like a lower sum. So this would be called a lower sum. So it's smaller than the actual area. And when, over here, when it's concave down like that, it's still lower. But what you notice is once we get to the second half of that, and now it's concave down and decreasing, now right here what I'm highlighting in green, that's extra. So that's called an upper sum, meaning right now it's over approximating, right? But before it was lower, so it was under approximating. Same thing for right hand, it's literally the exact same, but it's just flipped. So if a left hand is under approximating, then a right hand will be over approximating. So where the left hand was under approximating, our right hand one is over approximating it, and then it switches to under approximating. So it really does depend on whether the graph is increasing or decreasing and its concavity. The midpoint always does both. So the midpoint's actually more accurate because a left hand or a right hand, every single rectangle is going to be a little bit off by either under or over. What the midpoint does is half of each point will under approximate it, and half of each point will have a little bit extra to over approximate it. So the midpoint, this one is, or let's use a different color. But yeah, this midpoint is always, or I'll say almost always, there are a couple exceptions, but we don't really run into them. But it's almost always more accurate than our left and our right Riemann sums, because it does both over and under approximate it. And then trapezoid's the best, because what trapezoid does is it gets really close, especially for a linear line. If you guys notice, if we zoom in here, for the linear line, the 2 points and that straight line between them, it's already on the graph. So for a linear line, a trapezoid rule is actually exactly accurate. Then once we get to the curve, it is a little bit off, but it's just so much little space. Now this one is a lower approximation, right? Because that's extra wasted space. But if we had made this keep going and we got down here, sometimes it does have an over approximation. So it still can have a lower value or a bit greater value like the upper sum. But the trapezoid, what we want to take away from this is, and again, I'll say almost always, so like I'd say like 95% of the time, 99% of the time, this will be the most accurate of our approximations. So this is our most accurate approximation. So why would you use like the left hand or the right hand instead of the midpoint or trapezoid? Does anyone have any like guesses for why you would want to use the left hand or the right hand instead? Why would you rather use it? Yeah, it's like way, way, way easier. So this formula, like the left hand formula, the right hand formula are pretty simple. That midpoint formula was, I don't know, I think it sucks. I actually like the trapezoid formula better than the midpoint, but they're both harder formulas. So that's why people use the left and the right hand approximation. But if you want to get more accurate, that's when you use the trapezoid or the midpoint formula. All right, so there's that. Any questions this time before, just on accuracy? Yeah, so an AP question might ask you which one's the most accurate. If it gives you the option of trapezoid, you're going to want to use trapezoid. If it gives you the option of midpoint, you'll probably want to use midpoint. And usually left hand and right hand, if it, they're exactly split in the middle, so that wouldn't really be the answer. All right, so there's that, and that's pretty much it for that.